Alright, so the last video cut off, so we're going to pick right back up where that left off. If you are given y equals the inverse sine of x, that means in order for this to be a function, we had to only look at a certain section of the original function. Now that original function is y equals sine of x. So you have to start with knowing that in order for this to happen, the original function had to be y equals sine of x. The second piece of that is that in order for your inverse to be a function, you can only look at the original from negative pi over 2 to positive pi over 2. And that's just because if you can use just that piece, you've got a low loop and a high loop, and they're not going to actually repeat each other when they flip over. You've got this one piece that's joint, and you're getting almost to these two pieces. So, for cosine, if you're going to deal with the inverse, you have to know that originally you had the original. You had to have originally y equals cosine of x. Now, because y equals sine of x and y equals cosine of x look the same but are just a little shifted from each other, y equals cosine of x has to be looked at only from 0 to pi. And tangent of x, to look at the inverse, you have to look at the original function over the same interval that we look at sine. So from negative pi over 2 to positive pi over 2. Alright, now that we've got what the original function should be and what we have to restrict those domains to, what I need you guys to understand is that when we restrict a domain, that means when you take the inverse and the x's and the y's switch, that restricted domain becomes your range. So when we go down here and talk about the inverse of all of these three functions, the domains we just wrote down are the ranges of the inverse. So for sine, we can write this as inverse sine of x or arc sine of x. Both mean the same thing. Now, if you'll think back to what we did a few classes ago, the domain of sine, the domain of the inverse, is the range of the original. The range of the original, it oscillates. You know how it just bounces? The two numbers it bounced between that entire time were negative 1 and 1. So that was the range of the original. It becomes the domain of the inverse. And then we already know what the range is because that was the domain of the restricted pieces that we just wrote down right above this. Cosine. Inverse cosine of x or arc cosine of x. Both of them mean inverse, swapping the x's and the y's. Remember that sine and cosine originally both had the same range. So that means their inverse's domain is still the same, from negative 1 to 1. And the range would then, of course, be 0 less than or equal to x less than or equal to pi. And last but definitely not least, we have tangent. And tangent, we have the inverse tangent of x. That can also be written as the arc tangent of x. Now, if you'll remember correctly, when we did graphing, tangent had the asymptotes, and it shot up to positive and negative infinity alongside those asymptotes. So my domain of my inverse is really all real numbers. But I'm only going to look at one set of that, so that way it doesn't create any type of discontinuity or any type of, not discontinuity, failure for the vertical line test. So I can only look at this. My range is only going to go from negative pi over 2. I wrote x on every single one of those. I'll have to go back and fix that. To positive pi over 2. Guys, range is y. So every single one of these should say y, not x. So remember, range is y, so write that down correctly.